Have you ever wondered what underlies the fabric of our universe? What if we tell you it's all about fields, not particles? Welcome to the fascinating world of quantum field theory, or QFT for short. This is no ordinary realm of science. Here we're delving into the very essence of reality, the fundamental framework of quantum physics. Quantum field theory ushers in a radical shift from classical physics, which primarily deals with particles. It's a game changer, a paradigm shift if you will. QFT focuses on fields, not particles. Now you might ask, what's a field? Well, imagine a vast invisible energy grid extending throughout the entire universe. That's a field. In quantum field theory, every particle we know, electrons, photons, quarks, you name it, has an associated field extending throughout spacetime. These fields aren't just lifeless, static entities, they're vibrant, dynamic, and buzzing with energy. Imagine plucking a guitar string. The string vibrates, creating a wave. In a similar way, when energy is added to a quantum field, it creates vibrations or waves. But here's where things get truly mind-boggling. These waves in quantum fields are what we perceive as particles. Yes, you heard it right. Particles, those tiny bits of matter we've always thought were the building blocks of the universe, are essentially excitations or vibrations in their respective fields. It's like watching a still pond suddenly disturbed by a pebble. That splash, that ripple, in the quantum world, that's a particle. This is the core of quantum field theory. A shift in perspective that takes us from a particle-focused view to a field-centered understanding of the universe. It's a vision that paints a picture, not just of isolated particles bouncing around, but of interconnected fields vibrating, resonating, and giving rise to the reality we experience. So, quantum field theory suggests that what we perceive as particles are merely excitations of their respective fields. This understanding may seem strange, even counterintuitive, but it's this very oddity that makes quantum field theory one of the most intriguing chapters of modern physics. It's an ongoing exploration of the universe's blueprint, a journey into the heart of reality itself. You might be wondering, what exactly is a quantum field? Well, let's try to unravel this profound concept in a simplified manner. Imagine the universe not as a vast emptiness filled with particles here and there, but as a sea of energy, brimming with potential. This energy exists everywhere, from the farthest galaxies to the smallest crevices of your coffee mug. That's what we call a quantum field. Now, these fields aren't just static backdrops, they're vibrant, teeming with activity. Picture a calm ocean, seemingly serene. But beneath the surface, there's a flurry of movement, currents flowing, waves forming, and creatures swimming. Similarly, quantum fields might appear calm and unchanging, but they're constantly buzzing with particles popping in and out of existence. This ceaseless dance of creation and annihilation is what we call quantum fluctuations. But what makes these fields truly fascinating is their ability to interact with each other. Think of it like a cosmic dance where each dancer or field influences the others. This interaction is what gives rise to the physical phenomena we see around us. It's the reason why magnets stick to your fridge or why the sun shines. It's even the reason why you're able to hear my voice right now. In fact, everything we know and experience is a result of these fields interacting with each other. The light you see, the sounds you hear, the warmth you feel, they're all a result of particles emerging from these fields, interacting and then disappearing back into the quantum sea. So, you see, quantum fields aren't just an abstract concept in a physicist's notebook. They're the very fabric of our existence, the fundamental building blocks of our reality. They're the invisible threads that weave together the cosmic tapestry we call the universe. In essence, quantum fields are the stage on which the drama of the universe unfolds. So, how do these quantum fields shape our universe? Well, quantum fields are not just static backdrops, they are dynamic and active participants in the grand cosmic ballet. They give rise to the fundamental forces of the universe. Yes, that's right, the forces that bind atoms, orchestrate the dance of planets, and even sculpt galaxies. Gravity, electromagnetic forces, and the strong and weak nuclear forces all emerge from the interactions of these quantum fields. Imagine a calm ocean. This is your quantum field at rest. However, when energy is added, this serene ocean starts to ripple. These ripples, these excitations, are what we observe as particles. In essence, particles are nothing more than excited states of their respective quantum fields. This is why physicists often say that particles are made of energy. For instance, an excited electromagnetic field results in the creation of photons, the particles of light. Similarly, excitations in the gravitational field give rise to hypothetical particles known as gravitons. This is how quantum fields breathe life into the universe, by creating the building blocks that make up everything we see around us. But quantum fields don't just create particles, they also mediate the interactions between them. For example, when an electron and a proton attract each other, what's really happening is that the electron is emitting a photon, which is then absorbed by the proton. This exchange of photons is what we perceive as the electromagnetic force. So in a way, quantum fields are the universe's grand puppeteers, pulling the strings of particles and forces, orchestrating the symphony of existence. They are the unseen artists, painting the cosmos with their intricate patterns of energy and matter. Thus, quantum field theory provides a comprehensive explanation for the fundamental structure and interactions in our universe. It's like having a backstage pass to the grandest show in all of existence, a sneak peek into the secret workings of the cosmos. Can quantum field theory impact our daily lives? The answer is a resounding yes. Quantum field theory, or QFT as it's often abbreviated, is not just a fascinating concept that exists solely within the realm of theoretical physics. It has real-world applications that have already begun to shape our lives and will continue to do so in the future. Consider quantum computers. Traditional computers operate on binary logic, using bits that are either ones or zeros. Quantum computers, on the other hand, leverage the principles of QFT to work with quantum bits, or qubits, that can exist in multiple states at once. This allows quantum computers to solve complex problems at speeds that are, quite frankly, mind-boggling compared to their conventional counterparts. They have the potential to revolutionize everything from cryptography to climate modeling, and QFT is the linchpin that makes it all possible. But the influence of QFT isn't limited to computing. It also plays a significant role in medical imaging techniques. Magnetic resonance imaging, or MRI, relies on quantum mechanics to create detailed images of the human body. The technology works by detecting the magnetic fields of hydrogen atoms in our bodies. Without our understanding of QFT, we wouldn't have the ability to visualize the inner workings of our bodies in such a non-invasive way, a feat that has unquestionably transformed the field of medicine. From these examples, it becomes clear that understanding QFT isn't just an academic exercise, it's a pathway to technological advancements that can improve our lives in tangible ways, from how we solve complex problems to how we diagnose and treat diseases. The potential applications of quantum field theory are vast, and we are only scratching the surface. As we progress in our understanding and manipulation of quantum fields, who knows what other revolutionary applications we might discover? The future is indeed promising, and the quantum world is ripe for exploration. Could quantum fields be the key to understanding and applying the law of attraction? As we unravel the enigma of the universe, quantum field theory, or QFT, shines a new light on our understanding of the law of attraction. This concept, which originated from the domain of metaphysics, is taking on a fresh shape through a quantum perspective. As per the law of attraction, our thoughts are said to have a magnetic pull, attracting similar energies. Theoretically, if our thoughts are vibrations propagating through the quantum fields, then we are, in essence, transmitting and receiving frequencies within this field. A deeper understanding of QFT can help us fathom how these quantum fields might influence our thoughts and, consequently, our reality. Quantum fields are ubiquitous. They don't just exist somewhere out there in the cosmos, but also right here, within and around us. Every thought we have creates a vibration in this field, potentially attracting similar energy vibrations. This concept seems to echo the law of attraction's central tenet, that like attracts like. This understanding of quantum fields can have practical applications in our daily lives, especially in effectively utilizing the law of attraction. Here are some tips. Firstly, maintain a positive mindset, as this would create positive vibrations in the quantum field, attracting desirable outcomes. Secondly, visualize clearly and frequently what you want to manifest. Visualizations create strong vibrations in the quantum field. Lastly, believe and be open to receive what you've asked for. Your belief is a powerful energy that resonates with the quantum field, magnetizing your desires towards you. Harnessing the power of quantum fields could potentially revolutionize our approach to personal development and manifestation. By consciously transmitting and receiving vibrations in this field, we can attract the experiences we desire, according to the law of attraction. As we stand on the brink of this fascinating convergence of science and spirituality, we can't help but marvel at the potential of using quantum field theory to shape our reality.